Hi class, I wanted to show you some things for quiz 3. So I have opened up an Excel spreadsheet for the normal distribution. So the first half of quiz 3 is from chapter 5, and we covered that in all of my recordings and my lectures. But the second half of quiz 3, sorry, the first half is from chapter 4, about probability distributions. And the second half is from chapter 5, the normal distribution. And some of it I covered and some of it I did not. So I wanted to just go back through and give you an overview of how to do things in Excel for the normal distribution. So I wanted to start out with the standard normal distribution, which is what we covered in section 5.1. And so remember, a standard normal distribution is just a normal distribution where the mean is 0 and the standard deviation is 1. So the way that I would find a probability given a z-score is with the formula norm.dist, the value of z, and then this is one way to do it, 0, 1, true. But the way that I had recommend that you do this is, oops, we can use equal norm, norm dot dist. So I want to remind you that if you use your down arrows and your up arrows, you can move around in here. And we want norm.s.dist. And the .s is for standard normal. So if we use that, we don't have to put in any mean or standard deviation. And I clicked enter instead of tab. That's why it popped out on me. So once I pick the one I want, if I hit tab, then it pulls up this formula. And then I just, for this one, you can see here underneath that I just need my z-score and whether or not cumulative is true. So I'm just going to grab that z-score and say true. These are always true. Okay. And then that gives me the area to the left of the curve. So this is the probability. In this case, this is the probability that z, it's this meant here, z is less than some value. So this gives me the probability that z is less than 1.73. Okay, and then if I want the probability that z is greater than a value, which is the probability that z is greater than 1.73. And I want to remind you, it doesn't matter whether I say, shoot, that was supposed to say greater than or greater than or equal to. It doesn't matter because this is a continuous distribution. So there is no value at the actual, there's no probability value associated with the z equals 1.73. So less than and less than or equal to are the same. So let me just add that in here. Probability z is less than or equal to 1.73 is the same as the probability, oops, put that in the wrong place. The probability that z is less than or equal to 1.73 is the same as the probability that z is strictly less than 1.73. And then again, the way that we find that is we use norm.s.dist. This is for standard normal when the mean is 0 and the standard deviation is 1. And we just put in that z-score, comma, true. When we use that formula, it gives us the area to the left of the value, or the probability that z is less than a certain value. If I want the probability that z is greater than that value, then I need to take 1 minus this number. So the probability that z is less than 1.73 is 0.958. So therefore, the probability that z is greater than 1.73 is 0.042 because these two have to add to 1. All right. And then when I want to find the probability that Z is between two values, here I listed the two values, and to get the probability that Z is between those two values, what I'm going to use here, just redo this instead, norm.s.dist. So this is the probability that Z is less than negative 0.75. Oops, I need to say true. Okay, and what this gives me here, this is the probability that Z is less than negative 0.75. Okay, and that's because this is, again, the area to the left. Okay, and then I put in also, I need the probability that Z is less than 1.23. Okay, and again, this is also the area to the left. And so for this one, I'm going to go equals norm.s.dist. Again, I move my arrow down and then hit the tab. Here's 1.23, comma, true. Okay, and so this is the area to, this first one is the area to the left of negative 0.75. The second one is the area to the left of 1.23. And then to find the probability that Z, this is the probability that negative 0.75 is less than Z. Again, it doesn't matter if I say less than or equal to, is less than 1.23. Okay, that's what this is. And so this is equal, and it's going to be that it's less than 1.23 minus the probability that it's less than negative 0.75. And I just want to show you, I'm going to draw this to show you why that works. So this is standard normal, so the mean is in the middle. So since I want the area sorry, I'm just drawing this on a graph for you guys. All right, so you should see my graph. Okay, so this is the negative 0.75. So the probability that Z is less than negative 0.75 is out here in the blue. And then what I want is this area in the black, which is the probability that Z is between negative 0.75 and positive 1.23. So that's this area. And so what I need to do is when I use norm.dist and negative 0.75 or norm.s.dist and negative 0.75, I get this blue area. And then when I do norm.s.dist 1.23 comma true, I get the blue and the black added together because I get everything to the left of 1.23. So that's why I need to subtract the one that's the black plus the blue. And then if I subtract off the blue, then I just get the area in the middle. So that's why we do it that way. So again, that's the reason that I do it that way. And so the area in between them, I just take the difference to get that. So I have the area to the left minus the area to the left. It's a little bigger. I didn't realize I was making this so small. Okay, so I'm taking the area to the left minus the area just lost my place. The area to the left of negative 0.75 minus the area to the, or sorry, the area to the left of 1.23 minus the area to the left of negative 0.075. So I take the difference and this is my correct answer. Okay. And then when it's normal, but it's not standard normal, that means for standard normal, remember, that means that the mean is 0 and the standard deviation is 1. When it's not standard normal, but just normal, then they'll always give us the mean mu and the standard deviation sigma. So let me go ahead and write this down. This is the mean, which is mu. And the standard deviation, which is sigma. Okay, and then they'll again give us some x value. So if I want the probability that x is less than, let me go ahead and make this 43. Then again, I'm going to use since this is not standard normal, I'm going to use norm, and we don't need to put the rounding in. It just makes it more confusing. Okay. So what I'm going to use is norm.dist, and then this is my x value. So here it says x, mean, standard deviation, and then this is always true. So x, which is what I want, that's what's here, x. Right. X, mu, sigma, and then I say that the cumulative is true. And then again, if I want the area, the probability that x is greater than, so in this case, this is the probability that x is greater than 43 for this example, then I use 1 minus the probability that it's less. So this is the area to the right, so it's 1 minus the area to the left. And then what I was showing here is this corresponds to a z-score of -1. So if you use that, you'll get the same answer. And then to make this round for you, because it asks for it rounded to 3 or 4 decimal places, just want to remind you that if you go up here, let me just move around because it gives you different things. So if we go to the home tab here, then over here under numbers, you can change how many decimal places it gives you the answer to. Okay, and it rounds for you automatically. So instead of telling it to round, I recommend if it's 3 decimal places, just go in here and move this. All right. So again, if they ask us to find the probability, so I showed you it for Z. So if they ask us to find the probability for just a normal distribution that's not standard normal, that X is between two values, you're going to put both of those. We need the mean, the standard deviation, and then the two X values. And then we'll calculate the probability that X is less than or equal to. So in this case, this is the probability that X is less than, here X1 is 74. And this is the probability that X is less than X2, and X2 was 79. So this one is the probability that X is less than 79. Okay, and then I want the probability that X is between those two values. So the way I find the probability that X is less than 74, again, let me just do this for you guys. So that's going to be equal norm dot dist. And then we put in our X value. This first one is 74, comma, mean, comma, sigma, comma, true. Extra parenthesis in there, we'll just get rid of that. Okay, and then to find the probability X is less than 79, we go equal norm dot dist 79, comma, mu, comma, sigma, comma, true. And then to find the probability that it's in between, we just take, it's always going to be, this one will have a larger probability, right? So we take that one minus that one. And then however many places they wanted it rounded to, you can just move this to get the right ones. Okay, and then the next section, so that's how we find probabilities for, probabilities are based on the area under the curve. All right, and then if we need to transform, so if they give us a probability and ask us to find either a z value or an x value, then we're going to use norm.inv. And then once we find the z, that's always going to return a z-score. So then, well, if we use, sorry, if you find a standard normal, you could use this formula to convert it. But actually, we can do this the same way we did up here. So there's a norm.s.inv for the standard normal and just a norm.inv for the regular normal. So if it says, if we're given a cumulative area under the curve and told to find the z-score, so if they color in the curve and they give us the area to the left, and they say the area is 0.0778, then the way that we get this, norm.s.inv, I don't think these give us anything different. Oh, it does. Okay, so if we use norm.s.inv and we put in our area, that's all we put in. And so the z value is 1.42. If they happen to give you the area to the right of the z, or the area to the right, and then they're asking you to find this, then you would want to use 1 minus that area to get your z-score. Okay, and then when they want us to find it, oh, and then if they give us something like this, let me just move this over a little bit. If they tell you that 80% of the distribution area lies between negative z and ask you to find the two z-scores, then in this case, I want you to remember, let me draw this out, that that they're saying that 80% is in the middle of the normal curve. Okay, so let me just show you that. All right, so what it's saying is this area in the middle is 0.8, 80% of the probability that z is between negative z and z is 0.80. So what that means is that if I take 1 minus that, I have 0.20 left, and that's how much is in these two tails, which means that this tail has 10% and this tail has 10%. Okay, so I just went ahead and wrote that on my board. So what that means is that if I take 1 minus that area in the middle, I get 0.20. And so if I divide that by 2, I get 0.10. So there's 0.10 here and 0.10 here. And so now I can find, so the area to the right, or to the left, sorry, the area to the left of negative z is 0.10. So the way that I would do this in Excel is this means that there is 80% between negative z and z. So there is 20% or 0.20 in the two tails. Each tail has 0.10. Oops. So what this means is the probability that z is less than negative z probability that z is less than negative z is 0.10. So the way that I find z, or negative z rather, I'm going to go negative z. Oh. Well, let me put that in. Okay, so the way I find our negative z is I go equal norm dot s dot inv, since I have a standard normal, norm dot s dot inv, and then I just put in the probability, which is 0.1. And that gives me negative 1.28. And that means that my positive z is just the absolute value of this. right, because of symmetry, but I want to show you that that also equals, if I add the 0.1 that's in that left tail, along with the 80% that's between the two, this is the 90th percentile. So I go equal norm dot s dot inv, and then I'm going to put in 0.9. And notice it gives me the same answer, okay? So this is my negative z, and this is my positive z. Okay, so that's how we do that when we have a standard normal. If we have normal but not standard normal, then we're given a mean and a standard deviation. And so if it asks me to find the bottom 20%, or the, well, in this case, if they ask me to find the top 20%, so remember, then they're asking me for the area to the right, but the table always returns the area to the left. So this means that the area to the right is 0.2, which means that the area to the left is 0.8. So this is the area to the left, which is what we got when we do our norm.inv. So here, you can solve this by finding the z-score. So here we can use norm.inv. I don't know what I was doing over here. So I could find a z-score and then again use this conversion, but I don't need to do this. I can just find it right away. So this is where I did that. So I just go equal norm.inv, norm.inv, hit the tab, okay, and then I put in my probability 0.8, and then my probability mu sigma, probability comma mu comma sigma. And so I can do it two ways. I can find the z value, but or I can find it straight. So there's no reason to find the z value. Okay, if they asked me for the bottom 1%, that is the area to the left. So again, you don't have to find the z first. I know this is how my stat lab shows you to do it, but we're going to do it this way. So we're just going to go equal norm.inv tab, and then our probability, so I didn't put that in, 0.01 comma mu comma sigma, and that's it. And that gives me the bottom 1%. All right, and then those were the things that were not quite covered in the homework. We did it for the standard normal, but not the normal distribution. So I wanted to make sure that you understood so that you can finish your quiz. So you should now be able to finish your quiz, and I really hope that this helped. If you still have questions, please let me know.